With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone. So our question is, 100 kg of block is started with a speed of 2 meter per second on a long rough belt kept fixed in a horizontal position. The coefficient of kinetic friction between the block and the belt is 0.2. In the first part, we have to calculate the change in the internal energy of the block belt system as the block comes to a stop on the belt. In the second part, consider the situation from a frame of reference moving at 2 meters per second along the initial velocity of the block as seen from this frame. The block is gently put on a moving belt and is in the due time the block starts moving with the belt at 2 meters per second. Calculate the increase in the kinetic energy of the block as it stops slipping past the belt. In the third part, find the work done in this frame by the external force holding the belt. Okay, so basically we have been given a condition where a block is kept on a long rough belt which is fixed in a horizontal place and moving with the velocity of 2 meters per second. The coefficient of friction between the belt and the block is given as 0.2, and we have to tell that in the first part we have to tell that what will be the change in the internal energy of the block belt system when the block comes to stop. Okay, so for the first part, let us suppose that this is a block. This is a block and it is kept on a rough horizontal surface like this. Okay, so this is our surface. Okay, we have been given the mass of the block as 100 kg, correct, and it is moving with the speed of initial velocity, that is 2 meters per second, and the coefficient of friction, kinetic friction mu k, is given as 0.2, correct. Now in the first part, what we have to tell is what will be the change in the internal energy of the block belt system. Okay, so when the block comes to the rest on the belt, okay, the kinetic energy will become 0 of the block belt system, correct. Since as we know that the energy is conserved, so kinetic energy lost by the block will be converted into some other energy, and this other energy is heat, which is generated due to the friction between the block and the belt. Okay, so the change in the internal energy, okay, change in the internal energy will be equal to the change in the kinetic energy lost. Okay, so kinetic energy lost, correct. So du will be equal to what? Kinetic energy lost, and kinetic energy lost will be given as half into mass into final velocity square minus half into mass into initial velocity square, correct. Now putting the values, mass is given as 100 and final velocity, as the block gets stopped, so final velocity will be 0 minus half into mass is 100 and initial velocity is given as 2 meter per second square, correct. So the loss in the kinetic energy will be what? 200 joules minus the negative sign here represents that the internal energy is decreasing. Okay, so the change in the internal energy is what we can say is 200 joules. Okay, so this is our answer, correct. Now in the second part, what we have been given is the whole situation is seen with a frame of reference which is also moving at 2 meter per second, correct. Now what we have to tell that when the block is put on this moving belt, in the due time the block starts moving with the belt at 2 meter per second. So we have to tell what will be the increase in the kinetic energy when the block stops slipping in the belt. Okay, so our frame of reference is also moving, so relative velocity will come into action. Okay, so calculate the velocities associated with the system. Okay, so for the B part, the velocity of frame is given as velocity of frame of reference. Let us suppose it is represented as uf, which is given as 2 meter per second. Correct. Now find the relative initial velocity. Okay, initial relative velocity correct. Let us represent it as u dash will be the initial velocity minus initial velocity of the frame. Correct. So initial velocity is given as 2 meter per second and the velocity of the frame is also 2 meter per second. So initial relative velocity will be 0 meter per second. Correct. Now find the final relative velocity. So final relative velocity. Okay, let us represent it as v dash. So it will be v minus final velocity of frame. Correct. From here the initial velocity of the block is 0 meter per second and the final velocity of the frame is 2 meter per second. From here what we get it as minus 2 meter per second. Correct. Now so when we calculate the increase in the kinetic energy, so kinetic energy increase in the kinetic energy, correct, increase in the kinetic energy will be equals to the final kinetic energy minus initial kinetic energy. Correct. So taking half m as common, so it will be v dash square minus u dash square. Correct. Now substituting the values, mass is given as 100 and the final velocity is minus 2 and the initial velocity is 0. Correct. From here the increase in the kinetic energy will be equal to how much? 200 joules. Correct. So our second part is also done. Now in the third part we have to calculate the work. Okay, so to calculate the work we need to find the force and the displacement. Okay, so friction force acting on the block will be given as let us suppose for the third part. Okay, find the friction force acting on the block and the belt. Okay, friction force. Correct. Friction force is equals to kinetic energy coefficient into n. Correct, where n is mass into acceleration due to gravity, mu k into mg. Correct. Mu k is given as 0.2, mass is given as 100 and acceleration due to gravity take it as 10. From here we get it as 200 Newton. Okay, so we have calculated the friction force. Now calculate the acceleration due to the friction force. Okay, so acceleration due to friction force. Correct. Now for the acceleration due to friction force is given as the friction force divided by mass. Correct. Friction force we have calculated is as 200 newtons and mass is 100 kg. Correct. From here what we get is 2 meter per second square. Correct. We have calculated the acceleration. Now distance moved by the block in this frame. Okay, so calculate the distance. So distance can be calculated as v dash square is equals to u dash square plus 2as. Correct. Now v dash square is minus 2. We have calculated in the second part. U dash square is 0 plus 2 into acceleration due to gravity is 2 meter per second into displacement. From here we get the displacement as 1 meter. Correct. We have calculated the displacement, so calculate the work done by this frictional force. Okay, so work done by the frictional force is force into displacement. Force we have calculated as 200 newtons and displacement is 1 meter, so it will be 200 joules. Correct. Now the work done by the belt to give the final velocity. Okay, so belt is also doing a work to give the final velocity of 2 meter per second. So work done by belt is given as half mv square. Correct. Now where half m is given as 100 and v dash is given as 4. Correct. V dash is, what is v dash? Minus 2 and minus 2 whole square is 4. Correct. Now From here what we get is 200 joules. So the final or the total work done, so total work done is work done by the friction plus work done by the belt will be 200 plus 200 or 400 joules. So our total work is 400 joules. Okay, so all our three parts are done and these are our answers. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubt and App today.